Good afternoon. I'm glad to be here to present this topic, debugging Windows 10 UWP application effectively. Actually, we know that the UWP application plays a very important role on the Windows 10, and it has a beautiful UI. It runs in the container, has more secure, and can be deployed to multiple devices. So it must be different from the general Win32 application. Understand those applications differences, handle them properly, will be very helpful for us to debug the UWP application and improve our investigation performance. So my name is Chris Lee. I'm the engineer from the Windows App Consult team. Now let's start. First of all, I want to explain that the UWP running mode. As we see that the UWP app actually running in the same user mode on the Windows 10. With the desktop bridge app, they also feel the similar problem as the normal Win32 application. For example, maybe it has some exception will crash. Maybe it has some slowness and cause no responding on the UI. And possibly the application has a high memory issue or high CPU issue. Everything is similar, but because the Win32 app can call the Win32 APIs directly, it's running in the full trust environment. But the UWP app and the desktop bridge app can only run in the container. Now we are using the MSIX packaging technology, so they are running in the MSIX container. It will have some differences comparing with the Win32 app. And now let's take a look at what is the UWP special things and we need to think about. First of all, you can see that UWP has its own life cycle. When we debugging the UWP application, we want to confirm that the life cycle status is exactly what we want. We don't want to debugging the UWP when it's running, but suddenly it becomes suspended. So how to control the life cycle for the UWP is a very important skill. Another thing is that UWP cannot be double-click run as a .exe. We have to launch the UWP through the start menu or using some protocol. So this is another difference. We know that the UWP writing in .NET, but when we compare the UWP as a debug version, the UWP actually running in .NET Core. But if we release this UWP, actually it's running in the .NET native. So different .NET status require us to know how to debug them differently, especially in the WinDbg. Okay. For the UWP application, not only about the main.exe process, but possibly we also need to care about the background processes. When it is a background task host, it will host our background task or app services inside. And for the runtime broker.exe, actually, it will check the application's permissions on the Windows 10 machine. Sometimes we found that the UWP application started by hand. Maybe it's an application issue. Maybe it's a runtime broker issue. We also need to think about. UWP application use lots of asynchronous application programming pattern. For example, we use async or await code in many places. So this means we need to identify the multiple threading debugging when we debug the UWP. How to do that? How to find the relationship between each thread? How to find the deadlock relationship is also one topic for us. On the UWP, actually, finally we are called the Windows Runtime COM APIs. So when we debugging the UWP application, we will find there are possibly many COM API calls. So we should be familiar with those call stack. This will be helpful for us to understand the UWP application behavior. Regarding the security part, as we see that the UWP running in the container, so we cannot use a leak track tool to attach the process directly. This is a big challenge for us to understand how the UWP use the memory, how does it consume the memory. And it's always running in the user context, it's not in the admin context. UWP easily to be run on multiple devices. Normally, we can use a device portal to check the remote application performance or to capture memory dump. But we know that sometimes we need to use the Visual Studio to run the remote machines debugging skills. So all things here. Now let's take a look about the debugging tools for UWP. UWP using the XAML UI. The how to reload the debugging maybe is a familiar concept for most of developers. But with the latest update of the Visual Studio 2019, it can support the how to reload even on the expand. Okay, and we can enable the XAML how to reload in the debug options side. It's I highlighted here. Okay, we can enable that, and then we press F5. We will see that there are some tips here. Okay, this UI is going to be how to reload the debugging. Let's see a demo. On the right side, this is my application. I already in the debugging status, and here is the expanded data source, and here is a button I want to show the difference. Let's take a look. Now I will try to change the button color directly in the Visual Studio. We don't need to recompile the whole application. It will just change it to the yellow button. And we can also change the button's position. For the expand resources, you can easily change the data resource. It will be reflected on the running UWP application directly. So this is easy for us to modify the UI, to understand the UI layout quickly from the Visual Studio 2019. This is another very important thing for debugging the UWP application. We call this the parallel stacks. With this feature, we can easily understand that the different thread relationship in the current UWP, and we can select one function name and jump to the source code. Let's take a look at with this quick demo. Now I will try to reproduce the issue. I have an application to create the deadlock symptom. Now I will click the slowness and click then in the Visual Studio, I will open the parallel stack option. Here I will create the deadlock issue. After a while, I stop we can pause the debugging. Okay. Then back to the parallel stacks. Now we see that the parallel stacks just list the different threads. Then we can switch different threads to understand why the application is not responding. So for example, I choose one UI thread, and I can see that this UI thread may call some asynchronous tasks on another thread. And then I select another thread. It's a synchronized thread. It will tell me that, okay, what happened on this thread. So there are some details, logic about that, but generally the UI thread tried to call the asynchronous thread, and this asynchronous thread call back the UI thread. So this happens on the deadlock pattern. So it's very convenient for us to debug similar issues. Next, let's talk about the performance profiler. We can use this for the most Win32 application as well. It's not only for the UWP. I mentioned it here because we can use this way to identify more about the CPU usage and the memory usage for UWP. To study it, just click Debug and Performance Profiler. Here is a quick demo. Okay. Actually, I create one application to create the high CPU usage from time to time. This is a performance profiler, performance monitor data I showed here. Now I'm going to reproduce debug this issue and reproduce the problem in the Visual Studio. I open the performance profiler and choose the memory usage, the CPU usage here. I start my application. And I want to see that the high memory usage, high CPU usage really happens. So after a while, the problem will be reproduced. Now we can stop the collection and take a quick look. here we can see that it gives us some quick idea about, okay, there are multiple functions really use the high CPU, right? So we can click the Open Details hyperlink right here. And remember that open the caller options at the upper left drop-down list. It will give us all function calling histories, and you can easily pick up the problem high CPU functions as well. Yeah, it's like a real call stack, and we select the function and identify the function source code. So here is how I create the high CPU part for the UWP application. It's really cool. The overall steps is similar for us to analyze the high memory, but I want to give you as an idea about that. We need to use a mixed mode to analyze the UWP application, because the UWP application .NET part is just like a language projection, and the real memory can be consumed in the native heap or native world. Let's take a look. I start my application, and it will give us a slight different UI. We can take snapshot. The snapshot actually means the memory dump. The Visual Studio will capture the memory dump for the problem. If we click the take snapshot, it will give us the application UI quickly. And I will wait for a while until the high memory really triggered in the UWP application. Maybe just 5 to 10 seconds, you will see the issue really happens here. So it can increase a lot, maybe several hundred megabytes. Now I can take another snapshot. Okay, it's just take quickly. Here I just created about 4 3D modules in my application, so it will take lots of memory because the 3D module is really a lot of data. After that, we will stop the collection, and it will help us to analyze the issue automatically. Now, I already did this work before, so we just take a look about the general information. Look at this. This is a manager heap. Actually, the manager heap just increased very, very small, right? But the number is obvious, right? Okay, this is one clue we found. Next, we will check the native heap. So just click the hyperlink of the UI, then it will jump to the heap analysis window. Let's start it. Okay, then the next window will open. So it will give us some information about the manager objects increased. We can see that it's like 4 objects here. And when we go to detail, we want to see, okay, this is just a number change. What happened in the native heap? Overall, most of the memory will be consumed in the native heap. We call the caller part. It will give us very clean information about what type the COM API calls on the Windows runtime. So we will connect the information between the manager heap and native heap, and then move forward. So it's very helpful for us to debug the UWP application. Of course, when we choose a mixed mode, it will take some time to do the analysis. Now let's take other useful tools. The WinDbg preview can be get from the Windows Store. It allows us to launch the application directly, and also you can choose the background task directly. Okay, this is very convenient if you use the WinDbg preview. Most of the time I use WinDbg and the PLMDebug for the complexity issue because the WinDbg is very powerful. Process Monitor and the Process Explorer will help us to identify which file is not be accessed by the UWP and how to troubleshoot that. We can get this from the Windows internals. For the .NET debugging scenario, we need to know that this part is good for the .NET Core, and this part is good for the .NET Native. When we debug the application in the WinDbg, instead of the Visual Studio, we need to know that we need to take control of the PLM. Here is a general method about how to control the PLM. All tools can be get from the Windows 10 SDK. We will enable debugger, and we can trigger the different package or lifecycle status can emulate the background tasks. If we use a Visual Studio, we have an opportunity to directly select the option here. It depends how you debug the application. If we want to get the WinDbg to target the background task, normally we will use these steps to get that. We can choose a package full name and background task ID and run the command. Let's see the demo. There's a background UWP application, and I will open the process window to launch that WinDbg command directly. Here we can see that it will directly attach to the background task host. Sorry. We can see this part. This actually is our background task host. It can be attached directly, and then you can debug the background task. It's just running, and it will capture data. If any exception happens, we can use the background task WinDbg to analyze it. This is more useful experience when we debug the .NET in the WinDbg. Here is the general steps about how you can use it to load the SOS debug extension correctly. And for most scenarios, we can use the .NET SOS to load the SOS extension for debugging. And the Max debugging extension also useful. So if you want to talk more about that, we can check this offline. This demo will show you how to load the SOS extension quickly. Use the installer SOS. Please remember that everything here is for the .NET Core. I run this installation command, then it will tell me how to load the SOS for the .NET debugging. After that, I run the loading steps, and I can check the .NET objects in the WinDbg easily. The command I run here is dump heap state or CLR stack. Here's a .NET stacks can be found from the WinDbg. For release version, we also need to run the same call-dir command to control the CLR debugging. It will load the SOS extension from the public symbol directly, and then you can use similar commands in the WinDbg to debug your .NET native UWP. The last part I want to mention that the UWP exception debugging behavior. This is very important because here is a general rule that we should add the app unhandled exception in our applications. But please remember that this is always not always be hit because in different core of your application, the exception handling behavior is also different. For example, here, I just want to call the non-exist file, right? And then the get file from the application URL will always trigger the file not found exception. So when I call this function directly without any extra statements, it will just handled by the thread context silently. You will never hit the application level exception handling. And for the second part, if we run the as task not wait, the application will just crash. Only the await async function will work properly it will hit the app level exception. So this means when we coding our UWP application, it's better for us to add necessary exception handling. Otherwise, you will get weird application exception behaviors. The next, when we debug the application, no matter what happens, it's better for you to understand we need to explicitly turn on the debug exception settings. Otherwise, it cannot hit the exception point as you expect. The last part is WinDbg preview general commands. This is very powerful because some exceptions cannot be handled by the Visual Studio. If you have lots of debugging, debugging reproduce scenarios, you will know that the Visual Studio normally cannot handle everything. So we will use WinDbg. And there are two commands is very useful. Use this to enable all .NET exception handling, and use this to enable the Windows runtime exception handling. And even for the most tough exception, 27C, it can also be handled by the WinDbg easily. Okay, we quickly go through the UWP differences and a useful debugging tool for UWP. So here is a reference for you if you have more interesting to look at how to debug the application in Visual Studio, how to use the skills to debug a UWP application. So this is my topic. So we will be Expert Connect and the debug bar. So if you have more questions about the debugging, you can talk to me. Thank you.